basically what you're going to do is you're going to you're going to make the indicated shape here. Like for example, this guy's a parallelogram. So we're going to make a parallelogram in this first one. Now for every single shape, I wanted to start off nice and easy for you. But for every single shape, you're given the point 0. Alright, I screwed it up. It's 3, 0 and 7, 0. So I'll make those changes. So basically you're going to be getting this point right here and this point right here. And this is going to be one of your sides. And you have to come up with the characteristics or use the characteristics to come up with the actual shape that we're dealing with. Now, for example, for a parallelogram, what do we know about opposite sides? Opposite sides are congruent and parallel. Now, if they're parallel, what do we know about their slopes? The slopes are equal. There's a couple worksheets. That worksheet right there, you might want to grab. So we need the same slopes. So if we just pick a slope out of thin air, it doesn't really matter. Say you want to go up 3, 1, 2, 3, and over 1. Up 3 and do the same thing and over 1. And I call that A, B, C, and D. I know A is at 3, 0. And like I said, I put these backwards. So when I put this up online, I'll change it. Don't worry about it. B is at 7, 0. C is at 8, 3. And D is at, the X value is 4, so it's at 4, 3. So now, do I have opposite sides that are congruent? In this case, yes, because I went up 3 and right 1, so 3 and 1, 3 and 1. You have the same components for if you wanted to draw the right triangle here, then the hypotenuses would be the same. This is 1, 2, 3, 4. This is 1, 2, 3, 4. Is AB parallel to DC? Are they ever going to hit each other? They're parallel. What's their slope? When you have a straight line that is perfectly flat like this, what's the slope? Zero. There's no slope at all to it, so there's zero slope. Now, we have to come up with lines, equations of lines, and this is the part that is the nice Algebra 1 review. So you have to find the equations of the lines that make up the 4 sides. Now, the nice thing is, if you have horizontal lines like this, horizontal lines are always in the form y is equal to a. Where A is where the line hits the y-axis. So for AB, where is this going to hit the y-axis? What number? Well, what's this point right here? 0. So I can say y equals 0 for this. Now for segment DC, where is this line going to intersect? At y equals 3. So if you have horizontal lines, that's what you're going to end up getting. If you have vertical lines, it's where you hit the x-axis. So it's the opposite of a horizontal line. So like if you're building a rectangle is going to have your vertical lines. So you're going to have like y equals, and then x equals, and x equals. Now, for the line that contains AD, what's my point for A? 3, 0. How about for B? I apologize, we're doing actually D. But you were right with B. B was 100% correct. D was 4, 3. Now, what's the slope? What's the slope that's a plus 3, that's a plus 1. So my slope, what's my change in y? It's plus 3. My change in x is plus 1. So my slope is equal to 3 over 1, which is 3. Now, what equation can we use to actually create the line? You guys remember this one? Now, I'm going to use this point because there's a 0 in there. And that's going to make it easier. If I use this point, it would work out just the same. Now, if I go y minus, well, what's the y value from here? From this point? 0. What's the slope? 3. Then it'd be x minus, what's my x value from the point? Which would be 3. Simplify this. Y minus 0 is what? Y. Distribute this. 3 times x is what? 3x. 3 times negative 3 is negative 9. So that equation is going to contain AD. Now for BC, we're going to do the exact same thing. B has the point 7, 0. C has the point 8, 3. Do I know my slope? Three and 1, 3 over 1, which is a 3. So now I'm going to use y minus y1 is equal to m times x minus x1 again. And I'm going to use this guy again because I have another 0. You want to use the points that are the easiest for you. If you used 8, 3, it would work out. You'd get the exact same equation. You just have to do a little bit extra work. Now, so we're going to go y minus, thank you, grab one of the worksheets right there, at the corner right there. So we got y minus, what's the y value from point B? 0. What's my slope? 3. X minus, what's my x value? 7. So now y minus 0 is y. I have to distribute here. 3 times x is 3x. 3 times 7 is negative 21. So, based on all the characteristics that we had, I was able to come up with the equations for the two lines that were horizontal. The nice thing is, I'll show you the rectangle after this. And then we were able to come up with the two lines that were slanted. Yeah. The 3 in front of the x. This 3 comes from right here. It's from the x coordinate of the point that we're looking at. So when you choose the point that you're looking at, and we chose A because A had a 0 in it, and just like B had a 0 in it, that's why that's 7. I would use that and the 0. Basically, you choose the easiest point you can. And the nice thing is, once you actually figure out what the shape is going to look like, which you want to do in the graph, then you can figure out what the lines are going to be. Now, with the rectangle is a little bit easier because we have this point and this point again. That's one side. Now, what's special about a rectangle? What's the measure of the angles? They're the same, which means they have to be 90 degrees. So what I have to do is this. Now, this doesn't have to be the rectangle you choose. If that's A, B, C, D, like that, as long as this side is 4 and this side is 3, as long as these two sides are different, you'll have a rectangle. If you made 4 by 4, it's a square. So you don't want to do that. Now, for segment AB, it's horizontal, so where does it hit the y-axis? Where does AB, if I extended it out, where would it hit the y-axis? 0. How about DC? Where would that hit the y-axis? It would hit it at 3. Now for AD, this is a vertical. So these are your verticals. Where it's x equals A, A is where the line is going to intersect the x-axis or hits the x-axis. So for AD, where does this line hit the x-axis? What number does it go through the x-axis at? 3. So it would be x equals 3. And for BC, what would this be? Where does it hit? It goes through 7, so x equals 7. And in this case, you're done. So you're either going to work through, and if you have diagonal lines, you're going to have to use y minus y1 equals m times x minus x1. If you have just your straight lines, horizontal or vertical, you're going to end up using these types of a situation. So use the rest of the hour to work on this, and do it at the end of the hour. Yes.